Everyone, Radical Tutor here explaining. In this video, we are going to look at the image and the range of linear transformation. Now, it is very precedent that before you go to the solvings of the image, you are supposed to know the definition or the description of the image. Also know that the image of linear transformation is also said to be the range of a linear transformation. So the word image can also be said to be the range of a linear transformation. Now, before we go to the solvings, let's look at how we describe or how we can describe the image of a linear transformation. So here we say that let a function f run from v to w. So if there is a function f which is running from v to w, so it's running from the domain to the range, be a linear transformation, then the image is defined as the f of v is equal to w. So if you put v in the f, the answer you get is the w. In other words, if you put the domain in the function, then you should get the range, and hence we call it as the range or the image of a linear transformation. That's how you describe the image or the range of a linear transformation. Having looked at this description of the image, let's look at how to solve or how to get the image of a linear transformation. Here is our example. So our example is going to be, so here is our example. Let's look at this example. So here is our example. We are saying that let us consider the transformation t of xyz, which is equal to the three functions given to your right hand side. So these are the functions given. We are given 1, 2, 3, and 4. Now, the question is find the basis and the dimension of the image. So find the basis. So the question is find the image. Let me just say, let's start with the image, then I'll come to the basis and the dimension later after I've solved. Now, how do you get the image of a linear transformation? Now, for you to get the image of a linear transformation is very simple. What you're supposed to do then is to put the functions, or rather the equations given, into an augmented matrix. So you need to put them in an augmented matrix, or rather just in a matrix, then reduce that matrix to either row echelon form or reduced row echelon form. Once you do that, then you'll be able to get the image of the linear transformation. So what you're going to do is, we are saying that solutions, you get your equation. So the first equation is this one, the second is that, third and fourth. So what you do is that, remember here you have x, 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 and x. So you get the first numbers for the x, put them in the first row. So the first numbers of x, we are going to put them in the first row, which are 1, 1, 1, 1, 2, and 3. What have I done? What I've done is I've gotten this first number for x, the second number, the first number for x, the first number for x, and the first number for x. From each equation, I've put them in a what? In a row like that. Then I'll go to y. I also do the same. So I'll get the first number of y, which is 1, 2, 3, and 4. I'll put them also here. I'll have 1, 2, 3, and 4. All right. Then from there, what you're going to do is you are going also to get the values of z. The values of z are which ones? The value of z, we have this 1, -3, -2, -2, -1 rather. So you put those, which are, so we have 1, -3, -2, and -1, like that. Now, after you put them in that order, what you're supposed to do is to reduce this matrix to either row echelon form or reduced echelon form. The matrix that you are going to get is what we are going to call as the image of a linear transformation. So by doing so, let's do that. So we are going to say, for us to reduce to row echelon form, or let me use the reduced row echelon form, where we know that if this is our reading entry, meaning that these two numbers here must be zeros. So by doing so, for us to get the 1 as 0, we are going to say we are in row 2. The formula is row 2 minus row 1. getting this number here, a 0, we'll do the same. We are going to say that we are in row 3. The formula is row 3 minus row 1. So by doing so, we are going to keep row 1 constant, which is 1, 1, 2, 3. And then we say 1 minus 1 is 0, 2 minus 1 is 1, 3 minus 2 is 1, 4 minus 3 is 1. What have I done? I'm subtracting this minus that, that minus that, that minus that, that minus that. Then we also go to row 3, this minus that, this minus that, this minus that, and so on and so forth. So by doing so, 1 minus 1 is 0, negative 3 minus 1 is negative 4. And then we are going to also say negative 2 minus 2. Negative 2 minus 2 is negative 4 as well. Then we have negative 1 minus 3. We get a negative 2. All right? Let me just double check. So I'm saying negative 1 minus 3, we get a negative 2. So we are going to have a negative 2 here. Now from there, we are also going, since we are reducing to reduced echelon form, meaning that we maintain this as our pivot, then we make this and these zeros. So by doing so, we are going to say here, for us to make this number a 0, we are going to say we are in row 1, the formula will be row 1 minus row 2. So we say we are in row 1, the formula is row 1 minus row 2. Then for us to make this a 0, we are going to say we are in row 3. So we are in row 3. The formula is row 3 plus 4 row 2. Alright, so let's do that. So meaning that in this case, we are keeping row 2 constant because this is our pivot. So we have 0, 1, 1, 1. And then we say for us to get numbers in row 1, we are subtracting row 1 minus row 2. So 1 minus 1 is a 1. 1 minus 1 is a 0. 2 minus 1, 2 here, minus this 1. We are going to get 2 minus 1, we are going to get a 1. 3 minus 1, we get a 2. We are done there. We go to row 3, getting the numbers. In row 3, we are using this formula here, where you are saying that you are in row 3. This will remain a 0, remember. This is what we are, the 4 is what we are getting a 0, so it is going to remain a 0. Now, we come here in row 4, in row 3, we have negative 4, so we have a negative 4 plus 4, row 2 is 1. We also get a 0 here. We come here, we are in row 3, which is row 3 is a negative 2, so we write negative 2 plus 4, row 2 is 1. Okay, so this is going to give us negative 2 plus 4 is a 2, so we are going to put a 2 here. All right, so from here, what we are going to do now is we are going to make this number a 1 here, because we are reducing this matrix to reduced echelon form. So we are going to make this a 1. So making this a 1, we are going to say that we are in row 3. So we say we are in row 3. The formula is 1 over 2 row 3. So we multiply 1 over 2 to row 3 so that this number a 2 is made a 1. So by doing so, we are going to have 1, 0, 1, 2, 0, 1, 1, 1, and 0, 0, 0, 1. Now, where are we getting this one? We are getting this one after multiplying this reciprocal of the 2 there. So we are getting this one. Now, after getting this one, that's when now you can make this and these zeros, because we are reducing to reduced echelon form. And one of the conditions of reduced echelon form says, if you have a reading entry in a row, it must be the only nonce row in that column. If this is so, this is also your reading entry, meaning that it must be the only nonce row in that column. If you come to this, if this is your reading entry, meaning that this and that must be made zeros. So that's what you're going to do. So for doing that, we are saying that we are in row 2. The formula is row 2, or I can start with row 1. So making the number in row 1 is 0, which is a 2 for that matter. We are going to say we are in row 1. The formula is row 1 minus 2 row 3. Then making this one 0, we are going to say we are in row 2. The formula is row 2 minus row 3. Then we are going to end up having, we keep row 3 constant, which is 0, 0, 0, 1. And then we are going to get the numbers in row 2 by simply just subtracting row 2 minus row 1. So 1 minus 1 is a 0, 1 minus 0 is a 1, 1 minus 0 is a 1, 0 minus 0 is a 0. We come here, this is what we are making a 0, so it will remain a 0. This was already made a 1, so it will remain a 1. This was already made a 0, so it will remain a 0. Coming to this one, this is row 1 is 1 minus 2 row 3 is a 0. So meaning that even this number also will be a 1. So after you've reduced your matrix to reduced row echelon form, I'm saying reduce your matrix to reduced row echelon form or to row echelon form. Whatever that you like yourself. If you want to, you can reduce to reduced row echelon form, or you can reduce to reduced row echelon form. Then what you end up having is what we call the image. So this is the answer that we've gotten after we've reduced our matrix to reduced row echelon form, meaning that this matrix we've gotten is what we call the image of the what? Of the linear transformation. So meaning that in this case our image is this matrix that we've gotten here. This is our image. All right, now another question says find the basis of the image. Now for you to get the basis of the image, you just say basis is equal to get these rows that you've obtained. So this one, and this one. So the image is just the number of non-zero vectors or number of non-zero rows that has remained after performing the row reduction. So if you are to put those in a set format in the curly brackets, then that becomes your basis. So meaning that your basis is going to be like this. You get the first vector there is 1, 0, 1, 0. The second one is 0, 1, 1, 0. The last one is 0, 0, 0, 1. All right. So now, if you just put these rows that are remaining after performing the non-zero rows that remains after performing row reduction, then that becomes your basis of the image. So this is the basis of the image. Then they can also ask you to get the dimension. So they can also ask you to get the dimension. Now, to get the dimension is simply to count how many of the basis vectors do you have. So in this case, you have 1, 2, 3. So you have 3 basis vectors, and therefore our dimension is 3. So in case where we got the last row maybe rows of zeros throughout, meaning that our basis was only going to be this and this in a set format, and our dimension was only going to be 2 if at all we got this last row a row of zeros. But in this case, we've not gotten a row of zeros. That means our basis will be all the rows there, put them in a set format, and our dimension is 1, 2, 3 because we don't have a row of zeros throughout. All right, thank you so much. That's how you get the basis, the dimension, and also the image of a linear transformation. Thank you so much for watching this video. This is the Radco Tutor. Kindly just follow the page. Click on the follow button. So let's support each other so that at least we can grow together. We can grow the numbers together. If you're on YouTube, kindly just subscribe on this channel so that you are able to be notified whenever I post videos. See you next time.